Welcome to this explainer on mastering hexadecimal representation for your computer science exams. We're going to learn exactly how to move way beyond basic memorization so you can actually secure those top marks. It is fantastic to have you here. Look, if you've ever walked out of an exam hall feeling absolutely great, only to get your paper back and realize you dropped crucial points on questions you were so sure you knew, you are in the exact right place. Today, we're discovering how to construct the kind of answers that examiners absolutely love, using hexadecimal representation as our core focus. Here is our game plan for today. We're going to cover the hexadecimal exam trap, the concept of meaning over memorization, the disciplined answering path, why context is everything, the 3-pass revision cycle, and we'll wrap up with the 4-prompt memory check. All right, part 1, the hexadecimal exam trap. So here is the absolute biggest mistake students make. If you're sitting there just writing down short, memorized labels on your exam paper, you are falling into a classic, predictable trap. In the rigorous structure of computer science exams, especially when we're talking about Cambridge IGCSE and O-level standards, simply recognizing a term just isn't enough. The absolute highest marks, those are heavily reserved for candidates who can show exactly how a concept actually operates within a live system. There's actually a really clear pattern of failure here, and you can think of this as an insider secret directly from the examiners themselves. Year after year, they see students losing marks for things like vague wording, skipping absolutely crucial process steps, or just naming a concept without explaining how it functions in reality. For example, you might correctly identify that a MAC address uses hexadecimal, right? But if you don't explain why it's used in that specific network device, your mark is capped. Stating an advantage without giving the underlying technical reason is a guaranteed way to just leave points sitting on the table. Moving on to part 2, meaning over memorization. To fix this, you have to completely shift your mindset. You need to start treating explanations as dynamic tools, rather than just static, boring facts. You've got to understand what digital problem hexadecimal actually solves. For instance, how it makes long, messy binary strings significantly easier for human programmers to read and debug. You need to know the practical consequences it has for a system. If you can answer the why and the so what, suddenly terminology becomes your secret weapon, rather than just a flashcard definition you're trying to recall. A really massive part of finding that meaning is drawing crystal clear boundaries between ideas. Confusing memory with storage, or maybe validation with verification, is an incredibly common and, let me tell you, costly pitfall. Knowing what a concept is not is honestly just as vital as knowing what it is. This kind of comparative reasoning is exactly the tool examiners use to separate the top-tier students from everybody else. Let's look at part 3, the disciplined answering path. You can think of this as a highly reliable algorithm for your exam responses. First step, identify exactly what the question wants. Is it asking for causes, effects, maybe design decisions? Second, classify the hardware or software involved. Third, sequence your explanation so logically that even a total beginner could follow it. And finally, step 4, anchor it right back to the specific scenario they gave you. If you follow this, you're going to build an examiner-approved response every single time. So before your pen even hits the paper, you need to pause. Ask yourself, what exactly is this task testing? Are they looking for a process explanation, hardware selection, binary manipulation? Because if you don't diagnose the demand correctly, you risk just blindly writing down everything you've ever learned about hexadecimal. Teachers call that the knowledge dump, and trust me, examiners are really not fans of having to dig through a rambling essay just to find a single valid point. Which brings us nicely to part 4. Context is everything. Now, if there is one golden rule you take away from today's explainer, make it this. Generic responses rarely get full marks, period. If your exam question involves a factory robot, a cybersecurity incident, or an embedded system, your explanation of hexadecimal must stay strictly inside that specific scenario. Dropping a generic definition of HTML colors won't save you if the question is specifically asking about MAC addresses on a local school network. It's super frustrating, but it is entirely possible to know the theoretical facts perfectly and still lose out on the highest marks. Why does this happen? Usually, it's because of a failure to tie that knowledge directly to the prompt. If the scenario is about designing a website, you need to talk about HTML color codes. If it's a low-level programming task, talk about memory dumps and machine code. You have to anchor your theory to their reality. Keeping in mind that hexadecimal patterns apply in real-world scenarios, everything from global banking and smartphones to secure communications and robotics really helps you justify why it's being used. When you can actually visualize how hexadecimal operates in an industrial control system versus, say, a retail database, explaining its advantages becomes second nature.
This kind of real-world transfer makes your answers rich, highly specific, and pretty much impossible for the examiner to ignore.
All right, part 5, the 3-pass revision cycle. Listen, reading a textbook once simply won't cut it. You need a structured strategy. Pass 1, secure those key definitions and those critical contrasts we talked about. Pass 2, rehearse your explanations, actually write out the processes or draw the diagrams. And Pass 3, focus heavily on exam adaptability. You're basically building a layered foundation, moving smoothly from basic recognition all the way to advanced, real-world application. That third pass, that is your absolute secret weapon. Computer science exam questions constantly combine raw theory with applied reasoning. You have to force yourself to justify your choices. Try changing the scenario in your practice questions. If a past paper question was about a database, stop and ask yourself, how would my answer change if this were about a robotic control system instead? Adaptability is the ultimate proof that you actually understand the material. Finally, part 6, the 4-prompt memory check. Consider this your ultimate diagnostic tool. You absolutely must be able to answer these 4 crucial prompts out loud for any given concept. 1, what is it? 2, how does it work? 3, where is it used? And 4, why is it better or worse than an alternative? If you can't answer all 4 of those smoothly, you've got a gap in your knowledge. And that's okay, but it means you need to go back and rebuild the topic using a worked example until those 4 answers flow completely naturally. When you can vocalize the what, the how, the where, and the why aloud, you have successfully transformed fragile, short-term memory into robust, highly adaptable exam power. You're no longer just crossing your fingers and hoping the right question comes up. You are fully prepared to dismantle whatever scenario they throw at you. So as you head into your next revision session, the choice is entirely yours. Are you going to settle for memorizing isolated short labels, or are you going to anchor your reasoning and actually secure those top marks? If examiners are specifically looking for the why, are you still just going to give them the what? Apply the 4-prompt check, anchor your context, and go master that exam. Thanks so much for joining this explainer.